full API pattern in .NET 9. This is a complementary video to our video on minimal APIs. You can find a link to the minimal API video in the description below. Just to recap, a minimal API is suited for a small API with just a handful of endpoints. Typically, it's manageable within a single file. The full API pattern, with controllers, services, data access, models, etc., helps to manage and maintain larger APIs. Think in terms of an API, where its endpoints can be arranged in more than one logical section. For example, endpoints for the HR section and endpoints for the sales section, etc. In this video, we'll demonstrate implementing the full API pattern in .NET 9. We'll create an ASP.NET Core Web API project. Select the .9 framework and tick Use Controllers. As you can see, the template has already got a controllers folder with a sample weather forecast controller. We'll get to the controller in a moment, but first, we need to set up the rest of the API pattern. There are several patterns you could use, for example, clean architecture, CQRS, and vertical architecture. But for our purposes, we'll use a sort of standard architecture. This is surprisingly close to a clean architecture. One difference is our layers will be in folders instead of separate DLL projects. In any case, we'll start with our models. We add a models folder and add a student class. This represents an entity in our database. It's pretty straightforward with a unique ID, a student name, grade, and age. Next, we'll add our data access layer that will contain the data context class. We'll be using Entity Framework to access a SQL Server database, so we need to install some Entity Framework NuGet packages. The first one is the foundation package, Microsoft.Entity Framework Core. We're using .NET 9, so we select a compatible version. Since we're doing code-first design, we need the design package to create the database and its tables from code. We need the SQL Server package because we'll be using a SQL Server database. And finally, the tools package for creating migrations and updating the database structure. With our Entity Framework packages loaded, we can add a data folder to our project and add a DB context class. We'll just call our class AppDBContext, but you can name it to whatever conventions you're using. It needs to inherit from DBContext and has a constructor with DBContext options. It also has one DB set for our students entity. Then in the app settings JSON file, we add a connection string to our database. We're using the Visual Studio built-in SQL Server and call it default connection. If you're using an external server like Microsoft SQL Server Express or something, you'll need to adjust your connection string accordingly. Since we'll be injecting our DB context into other classes later, we need to register it in the program.cs file. For the options, we say we're using SQL Server, and this is the name of our connection string. Our next step will be to create the actual database, so this is a good time to build your project. Right-click Connected Services and select Manage Connected Services. Under Connected Services, you'll see your connection string. Click the ellipses next to it and select Add Migration. Give the migration some meaningful name like Initial or First Migration, and check that your DB context is selected. Click Finish and the migration is generated for you. Click the ellipses again and this time choose Update Database. Make sure your DB context is selected and click Finish. The database is created using the migration. We can go check our new database using the SQL Server Object Explorer. If you're using SQL Server Express, for example, you could use your SQL Server Management Studio. Here we see our database with the student table. Viewing it in the designer, we see our table with its keys and the SQL command that created it. Next, we're going to add our services layer. This is like your application or business logic layer. You could use your DB context directly in your controller if there's no other logic or validation you need to apply to your data, but usually in more complex projects, there's additional business logic requirements. You want your controllers to use minimalistic code and not bog them down with business logic. The sole purpose of endpoints is to provide a communication relay between your front end and back end. So we add a services folder and add a student service class. This class will do all the student CRUD methods for us. We'll need our DB context, so we inject it into the student service. Here we see the traditional way of doing it by injecting the DB context into the constructor method and assigning it to a local variable. But now we can use a shorthand way and inject the DB context at the class name. The result is the same. Our first method will get all the students asynchronously. It uses the DB context to return the entire student entity in list form. Next, we'll get a student by ID. This will try to find a student with a matching ID, otherwise it will return null. Then we add a student with a create method. We update a student with our update method. It will attempt to update the student if it exists. When we call our DB context save changes method, it will return the number of records it updated. If this is 0, it couldn't find the student and no student was updated. In our delete method, we use our own getById method to retrieve the student with the specified ID. If it exists, we remove it, and again we check the result of our save changes method to see if a student record was actually removed. To inject this service into our controller, it needs an interface. We'll make it inherit from an interface with the same name. Add an interface class to the services folder and call it iStudentService. We'll let Copilot generate the method signatures for us. These are the exact signatures of the methods in our service class without the leading access modifiers. Then, we register the service in our program.cs file so we can inject it into our controller. Finally, we get to the controllers and their endpoints. It seems like a lot of setup for our simple demonstration, but remember, in a real-world complex API, there can be many controllers and many more endpoints. You could even have multiple data context classes for accessing different databases. The purpose of all this setup is to make management and maintenance of complex APIs easier. On with controllers. You can remove any weather forecast template stuff if you like. We won't be using it. Right-click the controllers folder and add a controller. We're going to add an empty API controller. You may notice there's an MVC controller. The purpose of MVC controllers is to return HTML views. They inherit from controller instead of controller base. We're interested in the API controller. We'll call it students controller. In the class name, we inject the student service. This is the student service interface, not the actual concrete class. Our first endpoint is a GET request. This calls our student services getAll method to return a list of all the students. The second endpoint calls our services getById to return a student with the matching ID if it exists. Otherwise, it returns a not found response. Then we have a post request to create a new student from the student JSON object passed by the request. It does a little validation to check that the request actually contains a student JSON object, then calls our services to create the student. Then the update method accepts an ID and a student object. It does some basic validation to see that the IDs match, then uses the service to update the student. If the service update method returns false, it means a student with that ID was not found. Otherwise, the method completes and returns no content. It could have returned OK if you prefer. Finally, the delete request takes an ID and asks the service to delete the student with that ID. If no student was deleted, the service method will return false and we can respond with a not found result. Otherwise, if it was deleted, it responds with no content. Again, you could have responded with OK if you like. Now, before testing our API, we can do a last build and check for any errors. Since Swagger is no longer supported in .NET 9, we're going to use another popular API tester called Scalar. Install the Scalar ASP.NET Core NuGet package. Then in the program.cs file, add the map scalar API reference command to the is development if statement. When you run your API, you can open your browser and go to your local host URL. You can find the URL in the launch settings under Properties. Run the API and open a browser. Paste the local host URL and add /scalar/v1 to it. Here you can see all your endpoints and models. Let's try the post request to add a new student. Select it under the endpoints and click Test Request. In the test window, add the JSON object of the new student. Leave the ID value at 0, since this will be auto-generated. Click Send and the student is added with its new ID number. Let's try a GET request. Select the Get by ID request and click Test. Now we have to provide it with an ID value under Variables. Click Test and the student is returned. We can test updating a student with the put request. Remember, for our update endpoint, we specified that the ID must be provided and it must match the ID in the given JSON object. Click Send, and we can see the no content responds as expected when the student was updated. Finally, let's try the delete request. But this time, we'll try giving it an ID of a student that doesn't exist. Click Send, and we get a 404 not found error as expected. Enter a valid ID and the student is deleted, and 204 no content is returned. Here's one last tip. See how all your endpoints have the same route name? If you want to give them more descriptive names, you can do that in your controller. Change the action method attribute of an endpoint to include a more descriptive name, as demonstrated here. Run your API and go to Scalar again. Now your endpoints are more descriptive, and you can see the change in the curl commands. Thank you for watching our video. For more tutorials on C#, hit subscribe and click the reminder. Give us a like so the video can be visible to more people.